Okay, guys, so in this video, we are going to compute the composition, and the composition is written using that circle notation. So we've got f circle g of x. So what is this little circle doing? So this is the same thing as computing f of g of x. That's just the notation for the composition. So what do we do there? So remember, start at the inside. So we're going to start at g of x and plug it into f. So the F machine takes something, so draw a box, and what it does, it takes it, it squares it, and then adds 7 to it. So we need to take the g of x and plug it into the box. Well, g of x, so we're going to compute f of g of x. So g of x was the square root of x plus 8. So we're going to put that in the box. And that is squared plus 7, right? But what happens when you square a square root? That would become just x plus 8 because square root and squared cancel each other out. So here we got x plus 8 plus 7, which is going to give me x plus 15. Okay, so that is here. But the harder question is, what about the domain? So here is the problem that may seem like the x plus 15 is defined for all real numbers, right? Because when you think about the domain, how can it be different from all real numbers? A lot of times we have to ask ourselves, did we have a division? Did we divide by 0 anywhere? No, there's no division. Did we take the square root? Well, in x plus 15, we did not take the square root. However, here's the however. When you figure out the domain of the composition, you have to first start with the domain of the function you were plugging in. And then go look at the domain of the composition and find the overlap between them. That would be the domain of the composition itself. Okay, so first you have to start with the domain of g of x, which is what you were plugging. Okay, so what is g of x? G of x is square root of x plus 8. Whatever is under the root, to find the domain, you're just going to take that whatever, so get rid of the root, and make it greater than or equal to 0. That's how you find the domain. So to solve this inequality, we're going to subtract negative 8 from both sides. And we're going to get x greater than or equal to negative 8. Because if x was less than negative 8, the g of x did not exist at those values of x. So you can't plug something that doesn't exist into something else, right? It's just not there, so the answer will also be not there. So how do we write x greater than or equal to negative 8 in interval notation? So if you draw a real line and somewhere is negative 8 and then negative infinity on this side, positive infinity on this side. So you need to go from negative 8 all the way higher, right? Because this is greater than or equal to. And the negative 8 itself is a solid dot, right? Because it's included, it's greater than or equal to. So here we're going to get negative 8 to infinity. All right, now let's compute g of f of x. So this is another circle thing. So this is g circle f of x. So what is that? That's g of f of x. So here you're going to plug f of x into the g. So let's rewrite g of something, which is, we're going to just draw a box, is square root of that something plus 8. So now what you want is plug the f of x into the box. Okay, so we've got f of x is x squared plus 7 and then plus 8. Okay, so that's your f of x, which is what I plugged in. So if you simplify that, that's going to give you x squared plus 15 under the root. Okay, so we're going to compute that. Okay, we got the square root of x squared plus 15. By the way, you can never break the square root at a plus sign. So if anybody wants to try to simplify it like this, that does not work. It does not work. This is not right. You can try plugging in, for example, x equals 2. So 2 squared is 4. 4 plus 15 is 19. Is square root of 19 equal? Well, here we would get what is 2 squared? 4. So that would be 2 plus square root of 15. No, it's not. You can check on the calculator. That's not going to work. So never try to simplify it, quote unquote, because it doesn't work. Okay, now regarding the domain. So that's going to be very interesting. First, start at the inside. Start at f of x and find the domain of f of x. Okay, so f of x is defined for all x values. This is just adding things, multiplying or squaring, whatever. There is no square root. There is no division by 0. So the domain of f of x, there is no restriction, all real numbers. Now, what about the composition? Okay, so now we do have a square root there, right? So you might be wondering, well, there is a square root, so we want to make sure that whatever is under the root is greater than or equal to 0. And here you could try to solve this, but if you solve it, like you would say, okay, x squared is greater than or equal to negative 15. The thing is, because x is squared, it's going to be a positive answer or 0. And positive answer or 0 is always greater than negative numbers. So this is going to be true for all real numbers. Please don't try to take the square root of both sides, God forbid. That is not going to work because you're going to get square root of a negative number, which is just imaginary something or other. But the conclusion here is that because x is squared, because if x wasn't squared, then you would have x greater than or equal to negative 15. But because x is squared, it's some kind of non-negative answer. When you, whatever x you plug, this is going to be a positive or 0, and that's always greater than negative 15. So here, actually, the domain is all real numbers.